Hello everybody, we're here to discuss mixed expressions and complex fractions. This is found in lesson 11-7 of your book. The good news is about this section of your book is that there's really nothing new. We're just going to stick with that same idea that we've been talking about for a while now about how rational expressions are really just the same as fractions. So with that in mind, let's look at example 1 where we have where we're going to change something from a mixed expression to a rational expression. And example 1 in your book looks a lot like this. And basically we want to add those together. So how do we add that together? We have to have something called a what? This part of the fraction is called a denominator, right? And you need to have the denominator on both of your expressions be the same. So the denominator on this fraction is just an x minus 1. So that means we have to have that same denominator over here. So if we're going to make this denominator, which right now is a 1, that invisible 1, we never write him, poor guy, so neglected. If we're going to make this guy have the same denominator as this guy, what we really need to do is multiply this expression, top and bottom, by this x minus 1. You're saying, Miss Holly, I was way ahead of you. Why did it take you so long to say that? But you know, sometimes I like to hear myself talk, right? Okay, so if this is my bottom expression, if that's my denominator, then I'm good. So what I want to do now is I want to distribute this through this expression. Because I'm multiplying this times this whole thing, that's going to give me a 2x minus 2 over x minus 1. And over here I have a plus 4 over x minus 1. Now I have that common denominator. So I can add the numerators together. I get 2x minus 2 plus 4 is a plus what? 2 over x minus 1. And that's how we're going to make our mixed expression into a rational expression. We're just going to add our fractions together. No worries. I want you to pause the video and try 1b on page 714. 1b, which is 5y over 4y plus 8 plus 5y. So pause this video right now so we can figure out what we need to do. Okay, now come back after you're done. And you should have realized that this 5y is the same thing as saying 5y over 1, right? So if I'm going to multiply that 5y over 1 and get this, or add that to something else, I need to have a common denominator, which in this case is going to be 4y plus 8 over 4y plus 8. Okay. So here we get a 5y over 4y plus 8. Plus 5y, let's see, 5y times 4y is actually going to be 20y squared. 5y times 8 is 40y over 4y plus 8. Okay, now we have our common denominator, so we can add the numerators together. I've got a 20y squared, that's the highest degreed term. The biggest exponent, the highest degree, 20y squared, and I've got 5y plus 40y is plus 45y over our common denominator of 4y plus 8. Okay, now it's always a good idea to see if you can factor anything out. So in the top, is there anything that's common between these two terms? Is there maybe a y in both of them? Yeah. How about a 5? Does 5 go into 20 and into 45? Yeah. Any more than 5? I don't see anything more than 5. So I'm going to factor out a 5y. And what I'm left with is 4y plus 8. Well, that's not so, it's not actually 4y plus 8, sorry. 5y comes out of here. And then here I have, when I factor out 5, I'm going to get a 9. 4y plus 9. And on the bottom, if I factor everything out that I can, I get a 4 and a y plus 2. Okay, and in this case, nothing cancels. So this would actually be the final answer. It never hurts to check to see if something might cancel. But a lot of times, if it doesn't cancel, the preferred answer is going to be the one that's above it. Okay. One question you might have had when we did this one was, well, why didn't we factor out that 4 plus 4 out of both of these here? And you can do that. It doesn't hurt anything. You would get a 4 times a y plus 2 right there. But when we do that, it doesn't change what we're going to use as our common denominator. We still need this whole thing to be our common denominator, and we need to multiply the top and bottom. So if this was bothering you, what I want you to do is to go back and just check it out and see that you get the same answer even if you factor that through right at the very beginning. Okay. Sorry for the sound effects we're having over here today. It's no worries. I'm pretty sure you can hear me better than anything else that's going on in the background. The next thing that we're going to do is something called complex fractions. And the first thing I want you to get over is, as soon as you hear the word complex fractions, you might think that it's a little harder than it actually is. Complex fractions only means that we're going to have fractions of fractions. I'm looking at example 3 in your book, where you have something that looks like this: 8t squared over v, all divided by, or all over, 4t over v cubed. Now, that's a fraction in the numerator and a fraction in the denominator. So, boy, oh boy, that isn't something that we necessarily like very well, right? But what I want you to do is think about it like this. This actually means the same thing as 8t squared over v divided by, because that's what this fraction bar always means, it just means we're dividing it, right? Divided by 4t over v cubed. And now we know how to deal with it, right? Now it's the same thing as 8t squared over v times v cubed over 4t. Well, and now it's even simpler because now I can cancel top to bottom. I've got 2, 1, because 4 goes into 8 2 times, right? I've got a t on the bottom and a t squared, so that leaves me with a t. T and t squared cancel so that I have just a t on top. And here I have a v on the bottom, and there's a v cubed, so that leaves me with v squared on top because I just subtract that one off, right? So my final answer ends up being 2tv squared. Cool. That wasn't as hard as it looked, was it? Now, doing this step makes it really clear exactly what we're doing, right? When we just took this denominator and put it there with the dividing. Makes it really, really clear what we're doing. But there's actually a shorter way where you can use a whole lot less pencil lead. And let me show you how that works. We're going to do the same problem, but we're going to use my shortcut method, okay? And I'm going to do this right over there. So we have our original problem was 8t squared over v, and that was divided by 4t over v cubed. All I need to do is flip the bottom fraction. So the bottom fraction's right here. I'm going to multiply by v cubed over 4t. But if I multiply the bottom by that, I also have to do that to the top. So I'm going to multiply by v cubed over 4t. This cancels. That cancels. Now I just have the top. I've got an 8, 4, so that leaves me with a 2. T squared on top and t on the bottom. 2 minus 1 leaves me with just a t. V on the bottom, v cubed on top. That leaves me with a v squared. So my final answer is 2tv squared. Right? Good. The even shorter way to do it is to skip this part right here, just to know that you're going to cancel it. And as soon as you see, I'll do it one more time, exactly the same problem. 8t squared over v divided by 4t over v cubed. And I can just do the whole thing in one big swoop. I can just write times v cubed over 4t and cancel that out because I flipped it when I brought it up there. See, this is now the numerator and this is in the denominator. And that is going to be, let's see, t squared, there's a t, should put it there, 8, 4, there's a 2, and v cubed is going to be v squared. So I can get the same answer 3 different ways. This is showing the most work. That first way that I did it uses the most work. But if that's what you need to do to get the right answer until you feel comfortable using these other methods, then you should do that. So I hope this made sense. We did the same problem 3 different ways. Stop the video and go back and try again if you want. But there are just 3 different ways and you get the same answer no matter which way you do it. Now I want you on your paper to do 3A at the bottom of page 715. 3A. So stop the video. As soon as you write down the problem, you can write down the problem right away. So we have a g cubed over h divided by b divided by gh cubed over b squared. Stop the video and simplify this on your own. Okay, now that you've got that done, you can come back, but don't come back to this problem until you've tried to do this on your own. We are going to multiply the bottom by a b squared over gh cubed. That cancels, but if I multiply that on the bottom, I have to multiply that on the top. Okay, so here I've got a b that cancels out with a b squared, like leaving me with a b. G cubed and g, which it leaves us with what? G squared. H and h cubed leaves us with an h squared. So our final answer is g squared b over h squared. How's that? Okay. Let us move on. One last example I'm going to do. You can look at the examples A and B, for A and B in your book. I'm actually going to do for uppercase A under the check your progress on page 716. I'm going to do that example. So we have an A plus 7 over 4 divided by A squared minus 49 divided by 10. Okay, exactly the same way that we were doing this before with our other complex fractions. We're going to flip the bottom, and when I multiply that on the bottom, I also have to multiply that on the top. Same thing. On the bottom, it completely cancels out. On the top, I'm going to have something cancel out. I know I've got a 4 here on the bottom and a 10 on the top. What number goes into both 4 and 10? I hope you said 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Okay. Getting a little messy, so I'm just going to rewrite it. No shame in rewriting a problem. And we are going to see what we have left. This is everything we have. Now, is there any other way that I can simplify this expression? Is there anything? I'm sure hoping that you're looking at this denominator and saying, you know I can do something here. What can we do with this denominator to make it more simple? We can factor that, right? How do you factor a squared minus 49? You remember that? There's nothing we can do on top right now, so let's just write it down. That way we won't forget about it. How do I factor a squared minus 49? I've got a difference of 2 squares. So that factors to an a plus 7 and an a minus 7. Oh, look at that. This cancels with that. And I am left with 5 over 2 times a minus 7. Yay! We did it. Okay? Just because you have a polynomial in your numerator or denominator does not change anything at all about this complex fraction. You do everything exactly the same way. And then you get to an expression that we've already talked about how to solve. So enjoy your homework. I hope you seriously have some fun with this. And we will talk about it some more in class.